You have met nCr when dealing with the binomial expansion of x plus y to the n, and you're probably familiar to a certain extent with the formula at the top of the page here. nCr is n factorial over n minus r factorial, and this is the same as n minus 1, n minus 2, until we get r numbers on the top divided by r factorial. First, let's look at 7c3. The lazy ones amongst you would just press the buttons on your calculator. But those who prefer not to do that will realize that we can do it quite easily using the second line, 7 times 6 times 5, that's 3 numbers on top, divided by 3 factorial. 3 factorial is 6, divides into 6, leaving with 7 times 5, which is 35. We can show that this agrees with the other formula. If we look at 7c3 is n factorial, that is 7 factorial, divided by n minus r, that is 7 minus 3, which is 4 factorial, and 3 factorial is r factorial. Writing this out in full, we get 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 4 times 3 times 2 times 1 times 3 factorial. Well, we can cancel the 4s, we can cancel the 3s, we can cancel the 2, we can cancel the 1 just for the sake of it, and we find that we are left just with, on the top line, 7 times 6 times 5, and on the bottom line, 3 factorial, which is what we get if we use the second formula here. What happens when we're looking at something really rather bigger? Let's suppose that we look at 20c7. 20c7. This would be very awkward to do without a calculator, and we use the nCr button on the calculator. This, if you don't know where it is press Shift followed by divides. So if I want 20c7, then I enter 20, I press Shift, I press divides, then 7 equals 77520, which of course is rather better than trying to do it all with pencil and paper. You've probably got some idea, or you should have some idea, that nCr is the number of ways you can choose R objects from n. What I want to do now is just to illustrate that idea. First of all, just look at 5 different colors of dice: orange, red, blue, green, and yellow. And what I want to do is to count the number of ways in which we can get 2 6s. We could get 2 6s by having a 6 on the orange, a 6 on the red, and miss out on the other 3. Or another way of doing it would be a 6 on the orange, not on the red, a 6 on the blue, not on the green, and not on the yellow. What I would like you to do now is to pause the video and write down all possible ways in which you can get 2 6s with the 5 dice. I said pause the video. Okay, how many ways did you get? You should have got 10 ways altogether. Can't get the screen to move. There it is. So we have 10 ways. done this fairly logically. The first one red, then if you're logical, the second, the third, the fourth, and the fifth could be a 6. So that's taking all of them with a 6 first. And how many ways can we do it? Now we don't look at a 6 in the first place, take a 6 in the second place, second and third, second and fourth, second and fifth. Now we've got all possible places or all possible arrangements with a 6 in the second place. So now let's put a 6 in the third place and the fourth, third and fifth. Got no more in the third place, so we have a 6 in the fourth place and the fifth. And if we do it like that, we can see that we have got all 10 possible arrangements and that there aren't any more. This is really the number of ways that we can choose 2 from 5 dice. We've chosen 2 from 5. It's the number of ways that we can choose 2 from 5. And we have 10 ways of choosing 2 dice from 5. That is what we mean by 5C2, 5 choose 2. And if we work that out, it's 5 times 4. That's 2 numbers on the top line, divided by 2 factorial. That is 20 divided by 2 is 10. So that agrees with what we had. I could use the same idea to find the number of ways of getting 3 6s with 7 dice. But this would get rather tedious if I went on trying to do this. I've started in a logical way. I could have all 3 6s first, or I could have 2 6s first and the third 6 there. I could have 2 6s and the third 6 there, and so on. But this is just the number of ways I can choose 3 dice from 7. So this is 7C3. And this is equal to 7 times 6 times 5 divided by 3 factorial. 3 factorial is 6, cancels with 6. 7 times 5 is 35. And so that is the number of ways that we can choose arrangements we can have for 3 6s from 7 dice.